Hi, and welcome to Mr. Garofalo's podcast. In today's episode, we are looking at solving literal equations and formulas. We're going to start with example number 10 today. In this equation, we're asked to solve for x, and ax plus b equals d minus cx. The first thing I want to notice here is that there are two terms that have x. There's ax here on the left and cx on the right. So let's get those terms together on the same side of the equation. We could start by adding cx to both sides. So we end up with ax plus cx plus b is equal to d. We'll continue by subtracting b from both sides, leaving us with ax plus cx equals d minus b. Now the next step of this problem is probably not one that most of us think of. We're going to use the distributive property. You might be saying, well, there's no parentheses. Why would we use the distributive property? Well, remember, we can use the distributive property in reverse if we have a common factor. We have a common factor here of x. So ax plus cx is really equivalent to x times the quantity a plus c. Right? Because we've distributed this back, x times a would be ax, and x times c would be cx. Now we can go ahead and divide by the quantity a plus c to both sides to solve for x. So x would be equal to d minus b over a plus c. There's number 10, solve for x. Let's look at the Pythagorean theorem question. We're asked to solve for one of the legs. Let's choose A. We could begin by subtracting b squared from both sides.
Good afternoon, Fort Jeff Middle School. Please disregard that bell. It is only 2 o'clock and not dismissal time. Again, please disregard that bell. Sorry for the bother.
Well, sorry for that interruption, but we're going to continue podcasting. So on the right side here, we'll have c squared minus b squared. Now we want to solve for a. Right now we're solved for a squared, so we'll need to take the square root of both sides. Square root of a squared to be a. And then we would want the square root of the hypotenuse squared minus one of the other legs squared. And that would be solved for a. So let's try that out. Let's say we had a right triangle that was, say, an unknown leg, a, and we had a known leg, say 15, and a hypotenuse, 17. So we could use this by substituting the values for c and b, right? This would be the square root of 17 squared minus 15 squared. 17 squared is 289, and 15 squared is 225. So we would be looking at the square root of the difference between 289 and 225, which would be 64. The square root of 64 would be 8. So a would be equal to 8. So we used this formula here. We still used it, but we used an equivalent formula that was already solved for the leg. Many of you might intuitively do this when you solve right triangle problems. If you had used the original formula, right, you would have had to subtract 225 from both sides anyway. So that subtraction is actually happening inside this radical here. Well, I hope this was helpful. Keep in mind that on your homework, there are a couple of problems where you're going to want to use the distributive property to factor. It will be helpful in solving. Well, good luck and see you in class.